This section's title tells us we'll be looking at how to adjust settings, or parameters, within the SGDRegressor machine learning algorithm, a specific type of linear regression that uses stochastic gradient descent to find the best fit. We'll focus on improving its training speed and how accurate its predictions are. I'm given a problem where the SGDRegressor is slow to train and doesn't make very good predictions. That's not ideal. I need to figure out how to fix it by adjusting the algorithm's settings. The core of the quiz. I need to identify which of several proposed changes to the SGDRegressor's parameters will make training faster and predictions more accurate. Option A suggests increasing ETAO, the learning rate. A higher learning rate means the algorithm takes bigger steps toward finding the best solution. Too big a step though, and it might miss the best solution completely, making it unstable. So, I'll need to think about a balance. Option B suggests reducing MAXITER, the maximum number of iterations or steps the algorithm takes to learn. Fewer steps mean less computation and faster training, but it may not find the best solution if it hasn't completed enough iterations. Option C involves increasing the penalty parameter, often controlled by a LPHA value in L1 or L2 regularization. This adds a penalty for complex models and it generally makes for simpler, more generalized models. While it might not speed training directly, it can help indirectly by preventing overfitting, which makes it easier for the model to learn. Option D focuses on changing TOL, the tolerance. This controls how close the solution needs to be to the absolute best solution before the algorithm stops. Making it smaller pushes the algorithm to find a more precise solution, but it means the algorithm might take more steps. I'm tuning the parameters of the SGDRegressor, a machine learning algorithm that uses stochastic gradient descent to fit a linear regression model. I'll adjust settings to speed up training and boost accuracy. Think of it like fine-tuning a car engine. You want the best performance with maximum efficiency. My SGDRegressor is running too slowly, and the predictions aren't very accurate. This could be because of several reasons, like inappropriate settings for the learning rate, or the model being too complex. I need to find a way to improve it. I'll increase the penalty strength, specifically the alpha value, which applies regularization. Regularization discourages overly complex models that tend to overfit the data. Think of it as adding constraints. It keeps the model simpler, preventing it from memorizing training data and improving performance on unseen data. A sort of Occam's razor for machine learning. This usually improves accuracy and can sometimes speed up convergence. I will use a smaller tolerance level. The tolerance, (toll), determines how precisely the model needs to converge before stopping. A smaller (toll) means more iterations, slightly increasing training time. However, it results in higher accuracy by pushing the model toward a more refined solution. It's a trade-off, a little more time for potentially much better results. It could decrease the maximum number of iterations, max_iter. This will make training significantly faster, but it also means I'm possibly stopping before the model finds the best solution. It's like prematurely ending a race. You might finish quicker, but your performance could suffer. Accuracy is potentially sacrificed for speed. Increasing the learning rate, (A to 0), significantly could be a bad idea. Think of the learning rate as the step size when searching for the best solution. Too big a step, and you might overshoot the best point, bouncing around erratically and never settling. It could prevent the model from converging to a good solution. It's like trying to walk across a tightrope with giant strides. This section's title tells us we're going to learn about how to adjust settings in the SGDRegressor, stochastic gradient descent regressor, algorithm, a machine learning tool used for predictions. We'll focus on parameters that influence speed and accuracy. This is the core question guiding our exploration. We're looking for parameter tweaks that speed up the model's learning process and, ideally, boost its predictive power. Increasing the penalty strength means making the model less likely to create a highly complex, overfit model. Think of it like this. Imagine you're drawing a line through scattered points. A strong penalty discourages the line from wiggling around every single point. It will try to find the best representation of the overall trend, improving its performance on new, unseen data. The ALPHA parameter directly controls the strength of this penalty. This typically does not directly improve the speed, but often, it improves accuracy and can lead to faster convergence, although it isn't a guarantee. The tolerance, TOL, parameter determines when the algorithm stops learning. A smaller tolerance means the algorithm will keep going until it's incredibly close to the best solution, leading to better accuracy but potentially slightly longer training. Think of it like polishing a gem. A lower tolerance means more polishing, better results, but more time. This affects the number of training cycles. Reducing the number of iterations will almost certainly make training faster. But I need to caution that it could also compromise accuracy because the algorithm may not fully converge to the optimal solution. It's a trade-off between speed and perfection. The learning rate, ETAO, determines how big a step the algorithm takes when adjusting the model's parameters during each training iteration. A larger learning rate can speed up the process but might cause the algorithm to overshoot and miss the best solution, or even fail to converge. It's a delicate balance. It's like trying to walk across a tightrope. A smaller step might be slower, but it is safer. A bigger step is faster, but potentially more dangerous. I'm analyzing the choices you have for adjusting the parameters of the SGDRegressor algorithm. We'll figure out which changes might speed up training or improve your model's accuracy. Let's dive into optimizing the SGDRegressor. We need to adjust parameters to find a balance between fast training and great model performance. I see you are working on improving the performance of the stochastic gradient descent regressor. We're going to find the best parameter tweaks. Increasing the penalty strength, specifically the alpha value, adds more weight to the regularization term. Think of it as adding a penalty for model complexity. This can prevent overfitting, where your model fits the training data too well and performs poorly on new data, and sometimes speeds up convergence. A smaller tolerance means the algorithm will keep refining the model until changes in the error are tiny. This means more iterations, slightly longer training, but better accuracy because the model gets closer to the best fit. Reducing the maximum number of iterations will make training faster, but it could result in an incomplete model, potentially harming accuracy. It's a trade-off, speed versus quality. After adjusting parameters, I need to carefully retrain and evaluate your model to see how it performs. This includes checking accuracy and other metrics. Increasing the learning rate too much can cause the model to jump around, never settling on a good solution. It's like taking huge steps in the dark. You might miss the goal completely. We want to find a good balance. I'm tuning the parameters of the SGDRegressor, a machine learning model that uses stochastic gradient descent to fit a linear regression. This involves adjusting settings that affect how quickly the model learns, training speed, and how well it performs on new data, model performance. It's like tweaking the settings on a complex machine to make it work faster and more accurately. I'll increase the penalty strength. This is a great idea. A larger penalty discourages the model from becoming too complex, preventing it from overfitting the training data. Think of it like adding a weight to make a model simpler and avoid overreacting to noise in the data. This often leads to better performance on new data and sometimes even faster convergence, though not directly. Alpha controls the strength of L1, lasso, or L2, ridge, regularization techniques. I'll decrease the tolerance. A smaller tolerance means I'll run more iterations until the changes in model's predictions become very tiny. This ensures the model gets very close to the optimal solution, improving accuracy. It's like aiming for the bullseye. A smaller tolerance makes me take more careful shots, but I'll hit closer to the center. Although this usually improves accuracy, it does increase training time slightly. I'm facing a problem. My model is training too slowly, and it's not performing well. I'm looking for ways to make it both faster and more accurate. I'll decrease the maximum number of iterations. This speeds up training, but the model might not fully converge to the best solution, potentially reducing accuracy. It's like setting a time limit on training. It's faster, but it might result in an incomplete solution. I'm not going to increase the learning rate too much. A very large learning rate may cause the algorithm to bounce around without settling down. It's like taking very large steps when walking toward a destination. I might overshoot it or never reach it. This would prevent the model from learning effectively. Eta 0 refers to the initial learning rate. This section's title tells us we're dealing with a multiple-choice question that tests my understanding of how to optimize the SGDRegressor in scikit-learn. SGDRegressor uses stochastic gradient descent to fit a linear regression model. That's a fancy way of saying it finds the best fitting line, or hyperplane in higher dimensions, by iteratively tweaking its parameters. We're looking at ways to make the process faster and more accurate. I'm facing a problem. My linear regression model, using SGDRegressor trains too slowly and performs poorly. I need to find ways to speed it up and get better results. This implies my current SGDRegressor settings aren't ideal. This instruction means I might need to select more than one option from the following choices to fix the problems. This indicates there might be multiple ways to optimize SGDRegressor. Eta 0 is the learning rate. It controls how big of a step the algorithm takes towards the best fitting line, or hyperplane, with each iteration. A large learning rate might cause the algorithm to overshoot the optimal solution and fail to converge, like taking giant leaps while trying to find a specific spot. It would lead to poor performance. Max_iter limits the number of iterations the algorithm runs. Reducing max_iter makes training faster, but the model might not have time to converge to the best solution. It's like stopping a journey before reaching the destination. Increasing the penalty strength, often controlled by alpha adds a penalty to the model's complexity. This usually prevents overfitting, where the model performs well on training data but poorly on new data. While it doesn't directly speed up training, a less complex model might converge faster and generalize better. Regularization helps prevent overfitting by adding a penalty for excessively complex models. Tall defines how small the change in the loss function needs to be before the algorithm stops. A smaller tall means it'll keep iterating until it finds a more precise solution, which increases accuracy but could slow down training. It's like wanting to measure something with extremely high precision which takes more time.